AI is a fundamentally different technology from anything we've seen before. And with it comes a new set of requirements. Training state-of-the-art models and running inference at scale requires trillions of simultaneous calculations across billions of parameters. This necessitates enormous amounts of compute resources. And what's more, empirical evidence from scaling laws suggests that the relationship is exponential, meaning orders of magnitude more compute are needed to unlock incremental gains in model performance. Evidently, infrastructure isn't just important, it is a critical enabler of higher performance AI, but existing CPU-based infrastructure simply will not cut it. This architecture was built for day-to-day web hosting and database management and running SaaS applications, workloads that rely on simple, fixed logic calculations and lightweight processing. AI workloads are different. They require massively parallel, matrix-based calculations that are computationally intensive and need to be able to scale dynamically to match the demands of training and inference workloads. Generalized clouds and their CPU-based architectures simply cannot meet AI's increasing demands and lack the necessary optimizations across the entire stack to unlock the performance required for AI. The world needs to rethink the data center. Traditional air-cooled facilities often cannot accommodate the extreme power and cooling requirements of modern GPU clusters. They experience significant retrofitting challenges, leading to power constraints and inefficient resource utilization. You need a new set of managed software services. These legacy cloud stacks include layers of software abstraction, hypervisors, virtual machines, and unnecessary managed services not built for AI that create latency and consume precious processing overhead. And because of these built-in layers of abstraction, generalized clouds also lack the visibility and automation required to rapidly detect and remediate infrastructure issues. This is a massive limitation given the need to effectively monitor infrastructure health as components are pushed to their limits. You need a new set of developer tools and a unified environment for running various orchestration frameworks, such as Slurm and Kubernetes, in parallel so that AI teams can maximize the efficiency of their infrastructure usage. And importantly, you need tools to automate the provisioning of infrastructure. The status quo today is that once a customer contracts for accelerated compute capacity, the process of manual GPU acceptance, provisioning, and burn-in testing can take weeks or months, resulting in slower iteration cycles and delayed time to market. The reality is that up to 65% of effective compute capacity embedded in GPUs is lost to system inefficiencies, creating what we refer to as the MFU, model flops utilization, gap. With AI enterprises needing every last bit of performance out of their compute, closing the MFU gap represents one of the most critical challenges they face. And that's exactly what we've built CoreWeave to solve. With CoreWeave, AI teams get up and running faster. They get immediate access to bleeding-edge infrastructure with the software and managed services needed to orchestrate, monitor, and optimize AI workloads. In short, they get the performance that they are spending billions to achieve. AI needs a new cloud to help close the MFU gap, and CoreWeave is that cloud.